Hello everyone, good afternoon. Today I'm here to talk to you about operations on functions. This is actually 6.5 in your book. I'm actually here today with my lovely assistant Emma. Say hello, Emma.
Hi.
Louder, no one can hear you.
Hi. There's no one in here. You're crazy.
Anyway, we're talking about operations. There are going to be 5 operations in this section. The first 4 are the old school add, subtract, multiply, and divide. But there is going to be a new operation. If you look right here, this new operation, if you circle, will be discussed on another day. It's new and it's kind of complicated, so we're going to spend a couple days just on that itself. All right. The important parts of this section won't be the actual operations, because those are going to be things that you know how to do already. So the things that we need to focus on are the notation, how we write things, and then the domains. The domains of the answers. All right, now let's first talk about notation. All right? We know that function notation is f of x. Right? But suppose I have more than one function in the same problem. Well, I can't use the letter f again because I've already used the letter f for the original function. Well, if I have a second function, I might call him g of x. You're going to see in your homework, you're going to have f of x, g of x. You'll also have like an h of x and a j of x. All right, let's take a look at the 4 functions that we have and just how we write them. The first function, the first operation is addition. If I have this right here, f plus g of x, that just means f of x plus g of x. If I have f minus g of x, that means just subtract the 2 functions from each other. Multiplication is f times g of x. You'll also sometimes just see fg of x. And that also means f times g of x. So that means f of x times g of x. And then lastly is division. F over g of x is just f of x divided by g of x. So those are how we write the 4 operations. Okay? This is going to be a lot of, combining like terms, multiplying terms, and dividing. Okay? Hey, I'm back. All right, now let's take a look at some actual examples. Before we do that, let's talk about the word domain. We know what domain is. It's all the values that you're allowed to plug in for x so that we get an answer for y. All right? Well, in this section, we're going to combine what we were doing with domains, and we're going to be finding the domains of each of these new functions that we produce. All right? So let's take a look at this. Suppose I'm given that f of x equals 2x squared minus 5x plus 3, and g of x equals x squared minus 1. The directions say perform the indicated operation and simplify as much as possible. Make sure and state the domain of each new function. Okay? All right, now let's take a look at this first problem. I want to do f plus g of x. Well, as I said, that just means f of x plus g of x. So does it make sense that I'm going to take the f equation, the 2x squared minus 5x plus 3, and just add it with the x squared minus 1? Now realistically, I'm a bad boy here because I should be putting parentheses around the first and the second. But the reality is with the math, addition doesn't really need parentheses. So a lot of times, just so that we don't complicate things, we don't show the parentheses. We can just do it with addition, right? Well, so isn't this a combining like terms thing, right? So if I add my like terms, I would get 2x squared plus 1x squared is 3x squared. Negative 5x stays the same, and then plus 3 and minus 1 is plus 2. So that's what f of x plus g of x equals. My domain. Guys, now this answer right here is the simplified answer. Okay? We do not find the domain from here. We always go back to the original before we simplify. Now in this, it doesn't matter because you get the same answer, but in certain examples, you'll see that it does matter. Would you agree? The domain of this, I only look for 2 red flags in domain. I look for x in the denominator of a fraction. Well, I don't have a denominator, so that's not a red flag. And x in an even radical. Well, again, I don't see any radicals at all, so I don't have any red flags. It's clear sailing. Blue skies all the way from negative infinity to positive infinity. Take a look at example B. In example B, I've got f minus g of x. So So this says take the f equation and subtract it with the terms of the g equation. Now in this case, parentheses are important, especially for that second function g of x. Because don't forget, I've got to subtract all of g of x from f of x. So that means I've got to distribute this negative to the x squared and to the negative 1. So that becomes a positive 1. Combining like terms, I'm going to get x squared minus 5x and then plus 4. Notice in this, by the way, when I say simplify, I'm not factoring, even though both the previous answer and this answer factoring isn't simplifying. The only way that factoring is going to be useful is if by factoring, that'll help me cancel. All right, so there's my final answer for the subtraction. All right, I should say f minus g of x equals this. And then my domain for this guy, well, again, there are no red flags, so it's all real numbers from negative infinity to positive infinity. All right, let's take a look at the next example. I've got f times g of x, right? To do f times g of x, I'm going to take the f equation, which again was 2x squared minus 5x plus 3, and I'm going to multiply that by the g equation, x squared minus 1. So it's what you guys like to call FOIL. Or in this case, since there's 3 terms in the first parentheses, it's FOIL. Okay. So when I multiply this, I get 2x squared times x squared is 2x to the 4th. I'm going to have 2x squared times negative 1 is negative 2x squared. I've distributed the 2x squared to everybody. Now I'm going to distribute the negative 5x to everybody in the second term. Second parentheses. Negative 5x times x squared is negative 5x cubed. Negative 5x times negative 1 is positive 5x. I've distributed him to everybody. Now let's do the 3. The 3 to the x squared is plus 3x squared. And the 3 and the negative 1 becomes minus 3. Combining like terms, I'm going to get 2x to the 4th. He didn't combine it with anybody. X cubed is minus 5x cubed because he didn't combine it with anybody. Now my x squared, I've got a negative 2x squared here and a positive 3x squared here. Those add to give me just a positive x squared. And then lastly, I've got a plus 5x and a minus 3. So f times g of x equals all this. Let's slide him over. Okay. So this is what f times g of x equals. Again, the domain, now again, I'm going to look back up to the original green expression here. There's no radicals. There are no x's in the denominator. The domain is negative infinity, positive infinity. All right? All right, last example right here. In the last example, I've got f divided by g of x. F divided by g of x. All right, so I'm going to take the f equation, which was, again, 2x squared minus 5x plus 3, divided by the g equation, which is x squared minus 1. Now, I need to try and see if I can simplify this. Well, if I try and factor this numerator, well, what factors of 6 multiply to give me 6 and add to give me negative 5? Well, negative 2 and negative 3. So if you factor that, you're going to get x minus 1 and 2x minus 3. Over, well, when I factor x squared minus 1, I get x minus 1 and x plus 1. Now notice I have common factors. The x minus 1 and the x minus 1 cancel, so my final answer is 2x minus 3 over x plus 1. And so that is what f over g of x equals. What's my domain? Well, notice that my answer canceled out to x minus 1. Should I exclude 1 from the domain or not? Well, again, the number 1 rule is always use the original problem to find out the domain. So, since I have an x in the denominator, I've got to say, x squared minus 1 can't equal 0. I always look at the beginning. Do not use the simplified one. If you do that, you're going to get it wrong. If you solve this, you get x squared can't equal 1, so x can't equal positive or negative 1.
No.
That's my friend Emma again. She's talking. Sorry about that. Let me just finish this up real quick. Great. All right, so I know that my domain should be from negative infinity to negative 1, yin yin, negative 1 to 1, yin yin, 1 to infinity. And that's how we find the domain of that division problem. And that's it. Do the first 4 problems on the worksheet, and we'll talk about it tomorrow.